Welcome back. Today on the bench we have an Astron VS-35M, which is the 35 amp peak Astron linear power supply, and it also has adjustable voltage and apparently adjustable current um, limiting. So I got this for parts or not working, and I thought, well, most of the components in here hopefully will be replaceable if they're damaged or unusable. So then I got it open and saw these monster capacitors. I thought, well, these are going to be not inexpensive to replace if they're bad, but everything should be replaceable generally, except for maybe the transformer. So plugged it in, turned it on. Everything seemed to work mostly, except when I tried to play with the variable voltage output, and then it was a bit shaky. So let's power it up here. So turn on the supply to it, turn it on, and everything looks pretty good right now. This is the is the output voltage? This is the output voltage. Yeah, okay. And that looks about right here. About 5.5. And so let's increase that. You can see it's a little bit wavery. I've cleaned, I think I've cleaned the contacts in the pot up a little bit by, oh, there we go. Look at that. So it's pretty bad as far as regulation of the voltage. Here, I have one lead clipped onto the one end of the pot and one on the other. Let's clip on in the middle and see what we're getting. I think that's clipped on not too well. So that actually stabilizes it a little bit. I think it either provides some load or capacitance. So now it's actually quite stable. But it'll still be a little hiccupy, if we move it. So I think basically what's happening is the contacts on the potentiometer are old and just probably dirty, and it's not providing very linear resistance, or just a very intermittent resistance. So so we can see when we vary the potentiometer, the output voltage to the chip is a little bit variable. Obviously, when we clip on, it's not as bad. So, because we actually have a little bit of the resistance of the meter actually helps out a little bit there. So luckily it came with a schematic, so we can take a look at the pot here. This right here is the voltage adjustment pot. So it's between pin 5 and 6, and ground, of course, you see. So that's this potentiometer. Oops. Zoom back out. It's this one right here. Of course, I don't really know if the current limit pot is in trouble. I guess we can kind of test that. That one's obviously right here. But I printed out the data sheet here, and we can see 5 and 6. We have the non-inverting input and the voltage reference, and then just a typical application circuit right here. We can see it's pretty much as the schematic goes. We have the non-inverting in the V reference, and then you'd have your potentiometer with a little bit of capacitance there. So what I'm thinking is the potentiometer is just probably dirty, and really you want a pretty stable potentiometer here, because that's going to provide your voltage stability on the output. So the non-metered versions of these without the adjustable output are, probably the stability is maybe a bit better in the long term than the stability of the metered one. depending on the potentiometers and how they age and how good they are from the start, how nice they are. So what I think I'm going to do is see what I have in the way of potentiometers. I may have to order something. Also, maybe I could just give it a fixed feedback or a fixed reference voltage and see if that fixes the problem as well, because that would tell me if this is the issue. But from the we saw the voltage back to the chip was pretty variable, so it looks as though that the control voltage to the chip is variable, so that's gonna probably be an indication that that's the problem. So I'm going to see what I have in the way of potentiometers spares. I don't think I have ones similar. Well, I have one similar to this, but I don't know if they'll fit exactly. So I'm going to see what I have in the way of potentiometers and see if we can fit one in and see if it fixes this very self-variable voltage on the output. All right, well, we have a small collection of potentiometers here. I have some other ones, but these are basically the ones that would fit. Here's the one out of here. I mean, one thing you could probably do is spray some contact cleaner in here and clean these contacts that are probably just dirty. They could be worn through a little bit, but they could probably just dirty. Looks like it's a 2.5 K potentiometer as well. So we can use other potentiometers, but it'd be nice to have one of a similar value. But we see it's actually only reading, well, it's all hooked up, so maybe we'll desolder it and see, but it's reading only 1.8 across, so it's either going or the circuit's having an effect on the resistance between it, which could be the case, I suppose. So it'd be nice to use maybe a 10 turn, although it's probably overkill. I'd probably just be spinning this thing all day to try to get what other voltage, but very stable resistance would be nice, because that translates directly into the output voltage. So you really kind of want something stable. It doesn't necessarily need to be super granular, because I mean, you can run your radio at a variety of different voltages, from 12 down to 14.4, so, or probably even lower than 12, whatever the check your manufacturer's sheet. But yeah, this would be nice, but unfortunately I'd have to drill this hole out a little bit, and I'm not sure if I want to do that. I won't have to drill it out too much, but I guess if it works and I like it, maybe I will. I have kind of a crummier potentiometer. I think it's a 10K. This is also a 10K, should work. Just doing a voltage divider. I don't think there's too much current draw from the circuit. Most likely very little, if to none. It's basically an op amp. And this is the only really one that it fits right off the bat. Obviously this pole here is a bit long, but may just hook it up to see how it works, and then go from there. This one has the closest is the closest lengthwise, so this could potentially work, but I don't know, have to play around and see. It would be interesting to throw some of these on. They're a little bit overkill. They're probably a little expensive to put on here. It's just gonna sit at 13, 7, 8, whatever. So I could potentially even just set it with some resistor divider. So I'm gonna solder one of these guys on, probably this one, and we'll just see if it clears up the problem. And if so, well, have to figure out what potentiometer to install permanently, and possibly replace this one too, or clean them. I don't have any nice contact cleaner, so and these are probably kind of low cost, so it'd be nice to get something pretty stable in there as well. So let me solder that in, and let's check the output voltage and see if it's nice and stable. All right, we're back. We have the potentiometer here, the new one. What is it, a 5K, I think? We have, of course, the, oops, let's turn this back to voltage. We have just the output voltage from that potentiometer hooked up here, and then we have the output voltage for the whole power supply on this one. So let's turn on our power here again. Okay, so we can see we have a, well, it looks like it probably have this hooked up backwards, but that's fine. We have a pretty stable power at the moment here, and very stable control voltage being applied. So let's turn that, see if we can get it up to, so it goes up to about 15. And I guess when it's at the peak, we're giving 0 volts control voltage to the chip, but it's the LM 723, and yeah, so it seems as though that fixed it. It's just the potentiometer is bad. Let's see what we get down to here. About a 1.5 volts and 7 volts to the let's switch this here. There you go. We got backwards there. So about 0 volts to the for the control voltage, and then very stable with even with this one. So I don't know how necessary the 10 turn is. We want our 13.7 volts. Let's see how difficult it is. It is pretty touchy, but I mean, we can get it. I mean, of course there's gonna be drop in the line when you're pulling a lot of current. Yeah, I'm not sure how this, I should probably check this current limit pot as well. I could probably just keep it up all the way and it'd probably be just fine. But I'll probably check this. I probably won't record it because it'll be the same deal as this one. So anyways, yeah, is the pot. If you have one of these VS-35Ms and one of if your voltage is, your output voltage is really unstable, you can, it may be the pot, so you may look into that. Let's see. Yeah, even if we add another digit there, it's fairly stable anyway. So I mean, that's probably good enough for me. Things are fairly stable. Let me see what the other pot is in case someone else has this issue. Let me see what the current one is. See, it's probably also 2.5K. Yep. Okay. The current pot is also 2.5K. So, yep. I do actually have 2 of these 10 turns, but you know, these are probably overkill. For one, they're gonna be overkill, and 2, you have to drill the case out. 3, they're probably at least $10 a piece, so that's $20 in pots that are kind of not needed, but we'll see. And also, gonna want to make sure you have your polarity right on this. Let me see. So I'm turning this clockwise, and it's decreasing the voltage. So I want to switch the positive and negative on this. I just hooked it up wrong to begin with there. So yeah, that's fairly stable. You know, quick, easy fix for these. If you have this problem, you know, this is probably fairly old. I'm not sure how old, but yeah, looks that's the issue. Let me actually disconnect this as well, because we did see it stabilize once we put the meter on there. I don't think it should really have that much effect. It is moving a little bit, but we're all the way at the end there. So I mean, that's maybe another reason to go with a 2.5K pot. It may be more stable, although this 5K seems perfectly fine. So, well, I hope that helped in some way. If you have one of these, or thinking about getting one, I did get this for parts are not working. So, other things obviously can go wrong with these, but a lot of the stuff is probably repairable. You have your output transistors in the back; those are going to be replaceable. If there's monster caps here, what are these? These are 25 volt, 51,000 microfarads. So pretty massive, guys, two of them. The transformer, you're not going to be able to replace that easily at all for final replacement. Some of these, another thing, before I put this all back together, some of these little electrolytics, probably going to test these guys out, see if those are still good. There's a few of them in here, probably worth taking a look at. If this, I'm not sure how old this is. It's probably, fairly old though. So, yeah, as long as you have it open, check for other stuff that's going. But all right, so it's mostly back together, and I actually decided to put the 10-turn pot in here, just because it is variable. From 1.5 volts to about 15 volts. I could potentially just use this as a power supply, for anything else. So it'd be nice to have some precision going on with that. So let's give it a test. I did have to drill it out, and the knob is out a little bit further, but I'm really not too concerned. I could always trim down the post there, but not too concerned, like I said, at the moment. Giving about 120 volts. Okay, so about 1.6 volts off the bat, and yeah, it takes quite a lot to ramp up the voltage here, but you can, if I want to do 7.1 volts, well, I can do it fairly precisely. Let's even see how close we can get. Yeah, I mean, we can get pretty close there. So yep, many turns, of course. Hopefully this pot will outlast well, at least last as long as the power supply. I haven't replaced this one. It seems okay. The current limit, I'm probably just going to leave it full open anyways for now. I don't see the need for any current limiting. So let's just go all the way to the top here. About 15 volts, 40.9. We want to keep it 13.7, 13.8 is where most people keep their equipment. So somewhere in there. So anyways, I'm gonna put all the screws back in, and I think it's good to go. So hope this helped. If you have one of these and you have some voltage stability problems, well, the potentiometers may be at fault. So I'll see you in the next one.